Cool, ready to go. It's 1:15. So, good afternoon. Everyone's tired after lunch. Don't fall asleep. A few familiar faces from my last session, but for the people that don't know me, I'm Simon Todd. I'm a technical solutions specialist for AI virtualization at Intel. So today I'm going to be talking about, obviously, private AI on VMware with Intel. So Cloud Foundation, architecture, strategies, as well as workloads as well. So it's not just around AI, it's around some of the workload modernization. So usual disclaimer slide, you can QR that, screenshot it, read it in a hotel room and fall asleep if you want to. So this is my agenda. So looking at modern workload and infrastructure challenges, perception challenges and demands around AI, also private AI, VMware's private AI with Intel, and I'll include some resources in there as well. So what are the challenges? Well, next generation workloads need more power, but this is becoming a bit of a problem because existing data centers are reaching their power limits, especially as they want to deploy out GPU workloads in there. Existing data center structural capacity, what I mean by that is some of the older data centers, the weight of GPUs, the structural integrity of the data center can't handle the weight. So this is also becoming a challenge. Energy infrastructure is scaling too slow. And what I mean by that is, getting new grid connectivity to new data centers, for example, is becoming a challenge. But AI is driving a lot of these power demands. So cryptocurrency has always been known to be a dirty hogger of power. But the interesting thing is cryptocurrency consumed 0.6% of the global electricity last year. Now, 0.6% in the grander scheme of things is quite a big number. But the prediction is that AI by 2030 is going to consume 3.5% of the global electricity. So now crypto doesn't look as dirty, okay? But AI is advancing us as a human race. So we've now taken the approach of, looking at workloads because we've optimized on data center efficiency. Power and cooling costs. There's a big focus on PUE ratings of data centers as part of a European directive. But we've never really focused on actually building efficiencies into the workloads themselves. So this actually has a positive effect that, reduces the TCO, delivers better performance, but it also improves on efficiency from a power perspective. So what I mean by accelerating the workloads is, from Xeon Gen 4 onwards has a bunch of accelerators in there. And these accelerators serve different purposes. So for example, a demo that I ran at GITEX in Dubai was around QAT. So we virtualized some Nginx servers, which are a good example of a workload for QAT, and we ran it just on the CPU without QAT enabled. So we've seen the idle wattage of the server was 270 watts. We ran the QAT workload. We've seen a bunch of cores go to maximum, and the server wattage went up to about 480 watts. We then ran the same workload on the same server, but leveraging the QAT accelerator. The server wattage remained at 270 watts. Only one core was used, but the throughput went from 4,000 transactions a second to 12,000 transactions a second without consuming any more power. So it's all about building workload efficiency in there as well. So we have a bunch of accelerators. I'm going to be talking about AMX separately because that's the AI side of things. But you can see here that we've got various different workloads that can leverage different accelerators on the CPU. For example, if you look at networking, we have specific Xeon CPUs designed for networking that contains Quick Assist or the QAT accelerator, as well as dynamic load balancing. Arguably, you could actually use both QAT and DLB in AI workloads as well, especially if you want encryption, especially if you want to load balance using Tanzu, for example, across your worker nodes for your AI workload itself. So you can see we're actually doing a lot more focus on this. And the software ecosystem is really building on this as well. From the perspective of when we first launched the accelerators, there wasn't that much software supported these accelerators, but now they're starting to catch up. It's like the Field of Dreams with Kevin Costner, build it and they will come. Well, that's exactly what's happened. So from a CPU perspective, we want to be able to deliver the best performance per watt with all the accelerators. So what we've also built now is what we call the Xeon TCO calculator. So what this allows you to do is it allows you to put in your existing CPU, okay, the amounts of servers you've got, so on and so forth, and then what you're going to move to. So if you're going, say, for example, from Generation 1 Xeon to Generation 4 or Generation 5 or even Generation 6 Xeon, it can build you a picture on how much node consolidation you can do, but it also gives you a nice report that tells you what your reduction in CO2 and your reduction in power is going to be. So when you take that to your CFO or your CIO and say, look, we can actually reduce our carbon footprint and save money because we're going to buy less hardware, who's not going to be happy? So that's the Xeon side of things for the workload efficiency with all these accelerators. So again, I mean, I spent many years at VMware with the vSAN sizing tool, and this is like that but on steroids because it's based around Xeon and it's based around the different workloads as well. So you can get to choose the type of workload, and vSphere is in there as well. So it's a very unique tool that's designed to build you a report that you can go and argue the case that we need to refresh this hardware. So, private AI, VMware Private AI on Intel. So firstly, let's look at the AI challenges. There's complexity. You know, we need to start deploying AI workloads, but we don't know where to start. Costs, everybody knows that GPU-based infrastructure from a certain vendor is going to be expensive. And the feedback that I got at VMware Explorer is, we're sick of buying hardware and then having to pay the same company licenses to use the hardware. Operationalizing. And this was a US slide, that's why it's got a Z. But you're used to using vSphere infrastructure today. So why change that? Why not use an infrastructure that you're so used to deploying workloads on today, but now you're deploying AI workloads? So operationalizing is also a concern or a challenge. The big one here is data security and privacy. This is actually one of the aspects that's driving more and more organizations to move from public cloud back to on-premise, because there's concerns around data security and privacy. And AI is driving a lot of that demand because you're putting your data into a system using a large language model, whether you're using RAG or whether you're inferencing directly off data and your large language model. There's the human impact as well. So, you know, responsible AI, I'm a big fan of this. And the session I was talking about earlier was about AI and autism. You know, there is a concern about the impact, the ethical impact of AI from every perspective. Now, when I speak to customers about AI, these are the usual things that I get. I can't run this on vSAN, can I? I need to invest heavily into my infrastructure. I need to buy a lot of GPUs. I can't get hold of the hardware is quite a frequent one. It's all a black box. I want to see what's happening. And many, many customers at VMware Explorer said to me, yeah, we don't have this capability because we use a certain vendor and it's all a box and we don't get to see what's happening. So then we start to look at, you know, the challenges with these existing solutions. And the first thing that comes up is we need more choice. You know, for the past few years, we've had one vendor, and vendor is obviously NVIDIA. When I speak to people about AI, that's the name that first comes to their head. Locked in, Software, this is the whole point around having to pay for software from the same company that you've bought the hardware from. Ability to scale, not only from a cost perspective, but also for getting hold of the hardware. I've seen many organizations that have gone down the route and they've got GPUs and they need to scale and they can't get the hardware, either because there's such a delay or because the cost is too high. But it's also about efficiency, especially from a power perspective. GPUs consume a lot of power. I mean, you look at a typical H100 or H200 system, you're talking about 10 kilowatts for 8 GPUs. That's a huge amount of power to find. But then we've also got some demands. So AI compute for enterprise, they want this capability to be able to be used efficiently as well as easily. Easy to use software tools and enterprise class open source models. One thing I heard a lot of Explore was we need open source. And I also deal a lot with the Open Compute Project and AI Sweden. That's all around open source models, open source frameworks, whether you're doing inferencing, whether you're doing data prep, whether you're doing machine learning, deep learning, they want these open source frameworks and models. Now, you should all be familiar with this slide, okay? I just want to point out that Cloud Foundation is the only requirement for it to be private AI. You don't need Tanzu, okay? Now, I've been working with a German telecommunications provider on this, and half of the company wants to use VMs, and half of the company wants to use Tanzu. And I said, I don't care which way you do it. You can do it either way, but Cloud Foundation is the requirement for it to be deemed VMware Private AI. Tanzu gives you the flexibility of being able to deploy in an automated fashion, like multiple workers, and they all talk to each other. If you deploy it as a virtual machine perspective, you then have to do some manual configurations. So there's pros and cons of either way. VMs give you a bit more control. Tanzu gives you the more automated deployment. But again, VCF is the only requirement. But then when we start to look at the bigger picture, this is the typical GPU scenario. I need more power. So I talk about the hybrid approach to AI. What I mean by that is you don't need a GPU for everything. You may not need a GPU at all. It all depends on what your requirements are. So this is where AMX comes in. Who in the room's heard of AMX? Not so many, okay? I'm going to be honest. From an Intel perspective, we've done a terrible job of marketing this because I talk to many customers and they go, we've never heard of this. We didn't even know this existed. So this is a dedicated accelerator on Xeon Gen 4, Gen 5, and Gen 6, and every future version of Xeon. It's an advanced matrix extension that basically allows you to run AI workloads, whether you're doing inferencing, whether you're doing training, whether you're doing data prep. You can do this on Xeon, but it's all based on requirements. Okay, and I've got a slide that comes up in a second that talks about when should I use the GPU versus the CPU. The interesting thing here is at VMware Explore, I had T-Systems talk about, this is the large German telecommunications provider, by the way, and they talked about how they're implementing generative AI within their organization based on Xeon. So what they're doing is they're taking, this was the challenge that they had. They want to be starting to offer AI capabilities in their cloud offering. So as the first step, what they decided to do was deploy an internal chatbot and upload all of their documentation regarding to their internal cloud infrastructure so that anybody internally can ask a question like, what servers do we use in our FCI environment? And because the documentation has been uploaded, you'll get a response from the chatbot based on the documentation, based on RAC. And this is something that I talk to a lot of people about, the days of fine-tuning and training models is sort of coming to an end, especially from a generative AI perspective, because RAG is taking over a lot of that, because you can take a large language model off the shelf and start to upload your own documentation, and it inferences from that documentation. So you don't need to do the fine-tuning anymore. So it's taking a little bit away from the demand of that compute for training models for generative AI. Now, on the Xeon CPUs, we have AMX, but it's getting faster, okay? So you can see here we've got Gen 4 in dark blue, Gen 5 gold in light blue, and Gen 5 platinum in green. And you can see there's a performance increase. The more cores you have, the better the inference is, because there's an AMX extension for every core. So if you assign a workload with 16 cores and it's a 32-core CPU, it's not going to use all of the AMX functionality of the CPU, which means from a virtualization perspective, you can deploy multiple AI workloads on the same system. So our 6th gen is actually even better than this, okay? So on 4th and 5th gen, we say from a large language model perspective, between 15 and 20 billion parameters. With Gen 6, we say 70 billion. So it's getting better, okay? Then, if I need a GPU, what's the options? So we now have Gaudi, and Gaudi is now supported on private AI with VMware. So it's giving capabilities similar, if not better, to the H100 and H200. It actually outperforms the H100 and H200 on a number of workloads with less power. So your 10 kilowatt system now becomes 8 kilowatts. So it's delivering the performance when you need it. Now, the use cases for Gaudi is typical any AI function. We have training on there, we have RAG on there. Now, from a virtualization perspective, you can have either 1, 2, 4, or 8 VMs consuming Gaudis. It's a one-to-one relationship from a Gaudi to a VM, so you can't share a Gaudi device amongst multiple VMs, but you can have multiple Gaudis on a single VM. So you could have one VM consuming 8 Gaudis in the system, or you can have 8 VMs consuming 1 Gaudi each, or somewhere in between. One thing that Gaudi doesn't support is virtual GPU. But in all fairness, in an AI workload, you're typically not going to want to split the GPU up for multiple workloads anyway, because the whole point of a dedicated AI accelerator is you want the time to train to be as fast as possible. So we're all part of the VMUG here. So in the future, we will have a product that will support vGPUs, and that's going to be an amalgamation of Gaudi as well as GPU Max. So 2 products are coming together to formalize a product called Falcon Shores. And that will support virtualized GPUs as well, because that's going to be a sort of like half, an ASIC and half of a silicon type deployment, okay? So it's going to give you that flexibility. Now, you guys are mainly virtual infrastructure, right? So you guys only care about this bit, okay? The Cloud Foundation part. What we have above that is what your data scientists care about. So from an Intel perspective, we've built what's called the Intel AI Suite, which, whether you deploy this with Tanzu or whether you deploy this in a VM, you can go to the AI website, you can say, right, I'm going to run this in Docker, and I'm going to be doing inferencing, and I'm going to be doing this on the CPU, and it will generate you a script that you need to run, which will download all of the Intel extensions into your virtual machine so that you can leverage this straight away. You don't need to do anything from a vSphere perspective, because AMX will automatically be upstream to the virtual machine. Okay, which is a really, really good point, because sometimes you have to do some special configuration, whereas AMX, providing it's the hardware versions the latest, the virtual machine hardware version, it will automatically upstream AMX to your VM. So when would I choose a GPU and when would I choose the CPU? So I've already called this one out. 15 to 20 billion parameters based on 4th and 5th Gen Xeon. 70 billion on Gen 6 Granite Rapids. Okay, so that's with all the performance cores. But aside from these, I always say to customers, what matters to you the most? Is it power and cost? Or is it time to train and time to inference? Is it response time? And depending on what your requirements is, depends on which way you choose. If you're more constrained with power and cost, then you'll do this on the CPU. If you're more concerned about, I need the fastest response time or the fastest time to train, then you're going to want to go down the dedicated AI accelerator route, like Gaudi, for example. So it's giving you the options to be a hybrid approach to AI. And I've actually seen customers that will deploy out a cluster and they will have Xeon-only nodes and then a couple of nodes with Gaudi. So they've got the best of both worlds so that they can pick and choose which workloads run where. Run it on Gaudi when you need to, but run it on the CPU for the most points. Data prep is always done on CPU. 2/3 of inferencing is done on Xeon today already. Machine learning, deep learning, that's where you need to decide then, do I do this on the CPU or do I do this on a dedicated accelerator? As we see future generations of Xeon, we'll see AMX get bigger and stronger. I mean, we've already taken a jump from 20 billion parameters to 70 billion. With Xeon 7, I don't know what the numbers are yet, but you'll see that there'll be a significant jump there as well. So just to wrap up here, vSAN or vSphere ready nodes based on 4th and 5th Gen Xeons already have this AI capability in the CPU. You just need to deploy the workload to consume it. No special settings required in vSphere. So built-in accelerators are more capable and are more AI aware than they were. So you can now do things on the CPU that you used to have to rely on a GPU to do. Private AI on VMware allows you to keep your data and your intellectual property private, which is a big concern around AI workloads, especially in public cloud and T-Systems are a classic example of this. We don't want our internal documentation uploading to public cloud. So privacy and data security is paramount for AI workloads. Some resources there. So this one, I've actually gone through this guide with a few customers already, and it's worked perfectly. So it's a whole guide on deploying Tanzu and deploying out your TKGs and consuming the AMX on the CPU. And this is what I did with T-Systems as well. So there's a number of resources there. Use those resources, have a look for some more information. Reach out to Intel and ask for more information on this as well. Like I say, AMX hasn't been advocated well enough. And I've even said that to our executive leadership team that we've done a really bad job of advocating this. So, on that, any questions? Got any questions, Duncan?
No. Set up in his little hardware separate to see, you have to be running to make sure you pull in all the.
So the minimum EVC level will be based on Sapphire Rapids. So Sapphire Rapids and Emerald Rapids are the same socket. Yeah, that's just the difference between Gen 4 and Gen 5. From a virtual machine hardware version, I can't remember whether it's virtual machine hardware 25 or something. I think it's that one. That one has to be that above that version to support AMX. But again, once your VM's running on that hardware level, you don't need to do anything else. It will upstream AMX.